way you would solve an equation. So if 12 is being subtracted, we're going to add it. And we have x is greater than or equal to 20.
Don't you, isn't this the same as, it would be the same as the equal sign, right?
Mm-hmm, exactly.
So, yeah, you plus 12 on both sides. And then, okay, so for the next one, it would be plus 8.
Plus 8.
And do it to the other side. See, this stuff I'm confident about.
Now, if you don't like this, you can flip it toward the m is in front. Just remember, if the arrow is pointing at the m, it has to stay. Oops.
When do you have to switch the signs though?
We'll get to that.
To be correct.
We will get to that. Okay, we'll add 14 to both sides. And we have d is less than or equal to negative 5. Okay, now the difference between an equation and an inequality is that we can graph these.
How so?
Well, first we start with a number line. And we put 0 on it. Now, I do not expect you guys or care if you put 20 little perfect lines till you get to 20. Just put a line on the correct side of the 0 and label it as 20. Like, don't stick 20 over, here. 20 is positive, so it goes on the positive side, right? Yes.
You might write a little bit bigger.
It won't fit.
You gotta move.
I might have to.
Okay. Now,
And you got your glasses on.
Thank you.
guys, I'm recording. If you have less than or equal to or greater than or equal to, when you graph your dot on the number line, it's going to be solid. If you have less than or greater than, you're going to graph an open dot. So we have greater than or equal to, so I'm going to put a solid dot on the 20. And so x is greater than 20. That means x is bigger than 20, so I'm going to shade the side where everything is larger than 20. Well, larger is on the right.
Miss Aiden,
Mm-hmm.
how long does it take for ibuprofen to kick in?
Approximately 30 minutes.
30 minutes?
Okay.
Sorry, poke my phone.
If m is less than 30, again, I'm going to put a 0. I'm going to put 30 on the correct side of 0. I have just a less than, so I'm going to put an open circle. On the side of the circle that has numbers that are less than 30 will be on the left. So I'm going to shade the left. Now, if your letter or variable is on the left and the numbers on the right, the arrow will point to the direction that you shade. But if you have a situation like here where 30 is greater than m, it doesn't point in the right direction. Okay. D less than or equal to negative 5. Negative 5 belongs on this side of the 0. I have a less than or equal to, so I'm going to color that circle in. And then everything less than falls on the left. Forgot my left and right there for a second. So I'm going to shade the left. Okay, so we subtract the same from both sides. We can graph this.
Your ring is really shiny.
This one.
Yeah. Oh. Pretty.
37 goes on this side of 0. We have a greater than, so that's going to be an open circle. And we shade the greater than side. Did I do set builder notation? I did not. I skipped set builder notation.
That sounds confusing.
Shame on me. Okay, set builder. You always have a brace. And then whatever letter you're using. And then you have a straight up and down line. This means x such that.
Such
and then
as?
such that,
Such
such that,
Such that.
such that.
such that x such that 20.
Nope.
X such that x greater or equal to 20.
Yeah,
What
this
is
is,
such
this
that?
says x such that x is greater than or equal to 20.
What is such that?
In mathematical terms, it's sort of like you're putting classifications on things. So I could say like students in class such that they attend class at 11 o'clock. Like I'm putting classification on you that you attend class at 11 o'clock. It's a mathematical term for classification.
So it's pretty much just saying x. And it's like a period.
Yeah, it's identifying your variable. So that's what the first x
So
or y or
it's
whatever
two
is for.
separate thoughts.
Yeah, it's identifying, okay, so we're saying, basically what set builder notation is we're saying, we're talking about x, and this is what we're saying about it.
Yeah.
So if we did m, we do m such that, so whatever letter you're talking about, and then you just put your, oops, not greater than 30, it's less than 30, I lied.
What does such that mean?
It's just it's a mathematical term for I'm giving something a classification, or I'm giving something a specific property. It's just descriptive. It's like I'm describing this now.
Oh, it's like words.
Yeah, it's like
Some word-
describing.
Something that describes math.
It's saying like m described as m is less than 30. Maybe is a better way to say it, but it's in math it's called such that. But you just draw a straight up and down line. If you just remember the pattern, you don't have to remember how to read it. Yeah.
So the next one would be g such that is g less than or equal to -5.
Exactly.
What do you get less than equal to?
Right here. So you always take whatever is written right here. Whatever's written right here goes there. So here. Now basically, essentially, these three statements are all saying the same thing, just in a different way. The first, x is greater than or equal to 20, is your basic general algebra statement.
And it's the most simple way.
And yeah, and then the graph is a pictorial, visual representation of the same thing. And then the set builder notation is a formal mathematical representation. Like this is formal. This is informal, this is formal, and in the middle it's a pretty picture. Okay, maybe it's not that pretty. I guess it depends on your aesthetic standards, but you get the idea. So if we're doing the same thing for the subtraction property, it won't change just because we subtracted from each side. We've got that. So we've solved it, we've graphed it, and then we put it into set builder notation.
What does that line mean again?
This one,
Yeah.
such that.
Such that.
In math, and when you talk in formal mathematical language, there's things that such that, therefore, we say let, things like we'll say let x be less than or equal to 20. Yeah, things like that. It's the language of proofs. Okay, so what are we going to do on this next one?
Mine's
Add
8.
8.
So P is less than or equal to 10. Anybody want to come draw the graph?
Just got some balls right now. This thing's weird. It makes a little noise.
Uh-huh.
And then it would be this side shaded?
Solid
Oh, wait.
circle first.
Yeah.
And
Can you see
then,
that?
yeah, but you need to color it in. And then, wait.
Wrong way.
P is less than 10, so which
Oh,
side is less than 10?
this side.
Yeah.
Okay. And then this.
Uh-huh.
Don't laugh if this looks weird, guys.
There you go.
Uh-oh, she knows something.
So I'm not going to subtract 4a from both sides because then I'll be left with nothing over here, right? So I'm going to subtract 3a from both sides. So 6 is less than a, or if I want to switch that and put the a on the left, I have a is greater than 6. Just remember the arrow has to point at the thing that it already pointed at. So I have 0, I have a 6, I have greater than, so that's an open circle. And everything that's greater than 6 is this side, right? Because I have 7, 8, 9, 100, million.
Yeah.
And in set builder notation,
What do they call us of that?
set builder notation, it's due to a branch of mathematics called set theory. And sets are just collections. And so basically I'm saying this is a collection of every number that I could plug in for A and be greater than 6. So that starts with like 6.0000000000000, a lot of zeros and then a 1 on up. So I could plug in 15 or 900 million, but I could not plug in 2. 2 would not be in this collection.
It's a lot of numbers.
If there's an infinite amount of numbers, right? So we kind of, I just did this, but we'll do it again. This is less than. It can also be called fewer than. We have greater than or more than. Okay. We have less than or equal to. It can also be called at most. And if you think about it, if you tell somebody, like they say, how much money do you have? And you say, well, at most I have like $6. That means you have $6 or you don't quite have $6. You have less than that, right? And then if you have greater than or equal to, that's the same thing as at least. You know, how much is it going to cost us to go to Disney this weekend? It's going to be at least $100 each.
For me, free. What? I get it for free.
Why?
When there's a prioritize mission.
So that's all very random and mathematical. But what does that mean in the real world? Let's say A is 10 and B is 2. Do you guys agree 10 is greater than 2?
Yeah.
And let's say C is 4. And I'm going to take 4 and I'm going to multiply it by 10, and I'm going to take 4 and I'm going to multiply it by 2, and I'm going to get 40 and 8. 40 is still greater than 8, right? So nothing changed. So I can multiply the inequality by the same positive number and it'll stay true on both sides. However, if A is greater than B and C is negative, in order to maintain truth, if I multiply both sides by negative, I have to switch the direction of the inequality.
Why do you keep looking at my phone, son? Hmm?
numbers. We'll use 10 and 2 again. 10 is greater than 2. We all agreed to that. Let's say I say C is equal to negative 3. So I'm going to multiply both sides by negative 3. So I get negative 30 and negative 6. Is negative 30 greater than negative 6? No, it's not. It's going to be less than. So the reason you have to flip the inequality when you multiply by a negative is you've essentially switched to the other side of the number line. So here we were in the side of the number line where 10 greater than 2, but over here we're now negative. So negative 30 is actually less than negative 6. And it works both directions. If I 3 is less than 5, but if I multiply both sides by negative 2, I'm going to have negative 6, negative 10, while negative 6 is greater than negative 10. First of all, it says, of the students surveyed at Madison High School, fewer than 84. Fewer than. That's that. So we're looking at fewer than 84. So we're going to have something is less than 84. Said that they have never purchased an item online. This is about 1/8 of those surveyed. 1/8 of, that means 1/8 times those surveyed. That's the students. So how many students were surveyed? Well, we don't know, so we want to call it X, Y,
S.
S. Okay, S for students. Okay, so I have 1/8 times S is less than 84. 1/8 S is the same thing as S divided by 8. Does that make sense? So in order to get rid of the division, I have to multiply both sides by 8. Or if you want to think about it, anytime you see a fraction times a variable and you need to clear it, you're going to multiply both sides by.
Zoom. I think you did it with your hand. Put your hand.
I didn't mean to. So we multiply both sides by the denominator. These two 8s will cancel each other out, so I'm just left with S. And 84 times 8 is 672. So less than 672 students were surveyed. I'll show you both. I'll show you method 1 and method 2. There may be more than 2 methods. These are just the 2 that. Okay, so I have negative 3/7 x is less than 21. To clear this, I'm going to take both sides of the fraction, or sorry, the inequality, and multiply them by the reciprocal. The reason I do this is these two will cancel each other out. I'm left with x. And over here, 3 will go into 21 7 times, and then I have 7 times 7. So that's going to give me negative 49. Now, you'll notice I did not write my inequality symbol again. I multiplied both sides by negative. So what was less than is now going to be greater than. And I have this little cute symbol for flip your inequality, and everybody said it looked too much like a 6. So I used to do that for flip. Do you guys think it looks too much like a 6?
No.
Okay, so that's my little symbol meaning flip your inequality. Now, if you don't like dealing with reciprocals of fractions, there's another way. Okay. We're going to use that same multiplied by the denominator. So I'm going to take that -3/7 and I'm going to multiply both sides by 7. And the reason I'm going to do that is because these two 7s are going to cancel out and I'm going to be left with -3x is less than 147. And then I'm going to divide by my numerator. So I'm going to divide both sides by -3. And again, I'm dividing by negative. So I'm going to flip my inequality. Sorry, that's negative. And I'm going to get x is greater than -49. So you can do either method. If you want to just multiply both sides by the reciprocal, because that's easier for you, do that. Or you can split the fraction in half, and you can multiply both sides by the denominator, and then divide both sides by the numerator. And that's because in a fraction, numerators are multiplying, denominators are dividing. So we're going to do the opposite of that. Make sense? So just remember, anytime you multiply or divide by negative, you have to flip. And in order to solve this inequality, we're going to divide both sides by 60. Only 8 does not divide by 60, but that's okay. I'm just going to reduce it. They'll both divide by 2. So I get 4/30.
We both divide by 8. Or you divide
Nope. 60 doesn't. Okay, over here, I'm going to divide both of these by -7. And remember that because I divided both sides by negative, I have to flip my inequality. So it's now going to be greater than instead of less than. And it's going to be -21. That's not what I meant to do. Sorry. So my first step is going to be to isolate the 11y. So I'm going to add 13 to both sides. Which leaves me with -11y is greater than 55. Then I will divide both sides by -11. Oh, and also because I divided by 11, that's negative, I'm going to flip my inequality. So that gives me y is less than -5. So same exact steps when you solve the equation. It's just the only difference is the symbol looks a little different. And if you use a negative, if you add or if you multiply or divide by a negative, you flip. Okay, I'm going to write and solve an inequality. So I have 5 minus 6 times a number is more than 4 times the number plus 45. Okay, this is more than and greater than are the same. 5 minus 6 times a number. N? Four times the number, it's going to be the same number, so 4 times the number plus 45. So this is essentially our inequality, so I'm going to rewrite that. Okay, so now I have variables on both sides of the equation. Do I want to move my 6n over with my 4n or my 4n over with my 6n?
Move the 4.
Okay, so we're going to subtract 4n from both sides. Which gives me 5 minus 10n is greater than 45. And I gotta get rid of this 5, and it's positive, so I'm gonna subtract it from both sides. Which is gonna give me negative 10n is greater than 40. And that's multiplication, so I need to divide. And I'm dividing by a negative, so I also need to flip my inequality symbol. So n is going to be less than negative 4. So in order for this to work, n would have to be less than negative 4. Using the distributive property. So anytime you see a situation like this, you're always going to distribute. Anytime you see this, you're going to distribute first. Okay. So I'm just going to rewrite this so that there's more room. I'm going to take that 4 and I'm going to distribute it into the 3t and the 5. So I'm going to get 12t plus 20 plus 7. Oh, not plus 20, sorry, minus 20. That 5 was negative. So minus 20 plus 7 is greater than 8t plus 3. The next thing I want to do is I want to collect like terms. Okay, so here's my like terms. So you have 12t minus 13 is greater than 8t plus 3. Then I'm going to move my t's all together. So subtract 8t from both sides. Which gives me 4t minus 13 is greater than 3. So then I'm going to add 13 to both sides. To get 4t is greater than 16. So I'll divide by 4. T is greater than 4. Can occur where we have no solutions or we have all possible solutions. So this occurs, first we have to try to solve the equation. So I'm going to distribute that negative 5 and the 4. So I get 9t minus 5t plus 25 is less than 4t minus 12. 9t minus 5t is 4t. So I get 4t plus 25 is less than 4t minus 12. If I subtract 4t from both sides, I get 25 is less than negative 12. No. Right? This is not true. So whenever this happens, whenever you get a not true statement, you have no solutions. Okay, very similar to when you get an equation where you get like 5 equals 17. 25 is not less than negative 12, so this is not true, so there are no solutions. Or, you can distribute this 3 and this 6. Okay, so I get 12m plus 18 is less than 12m plus 18. This is also not true. Okay, this is a typo, I'm sorry. That should be a less than or equal to, so if you could just fix that. So if I subtract 12m from both sides, I get 18 is less than or equal to 18. This is true. So it's all real numbers. Now, if I had had just less than, the way I had it when I realized I made a typo, if I got 18 is less than 18, that is not true. And so it would be no solutions again. Because 18 is not less than 18. 18 is equal to 18. So that's why I had to fix my mistake and make it less than or equal to, for it to be all real numbers.
What did they say, all real numbers?
All real numbers? Yeah. Or you could use just the symbol for real numbers.
Why?
Why? Because I could plug any number in there and it would make it true. Because they have a true statement. And there are no variables left, which tells me that the variables don't really matter. So I could plug in zeros, I could plug in 500, I could plug in negative 32, it'll still be true.